Hi there, everybody. This is a review video for Unit A. So the way this will work, you'll see a question, you'll work on it, you'll have the opportunity to answer it, and then you will hear the explanation for it. So let's get started. Again, this is a review video. So question number 1. Which of the following represents a physical change? So before we even look at the answer choices, let's just think back as to what a physical change is. We can say, we have no new substances that have been made. So if we look at each of the answer choices, let's look at what we have before the arrow and what we have after the arrow. So you'll see numbers here. Don't let that confuse you. Cross that out. You don't need to look at it. Okay? So if we look at choice A, we have H2O at the beginning on one side of the arrow, and we have H2O at the end. If we look at choice B, we have H2 and O2 in the beginning, and we have H2O at the end. So for B, it can't be B because what we have before and after the arrow is different. For choice C, we're starting with H2 and I2, and we're ending with HI. HI is different from H2 or I2, so it can't be that one. If we look at D, we're starting with N2 and we're starting with O2, and then at the end we're ending with NO2. Again, NO2 is different from N2 and O2, so it can't be that one. These three are great examples of chemical changes, but the question's asking about physical changes, so that means our answer is A. Question 2. What sample of carbon dioxide has definite shape and definite volume? Well, let's think. What has definite shape and definite volume? That is the definition of a solid. So these little things here, those letters, tell you what phase of matter it is. So AQ means aqueous. And what that means, it's just CO2 dissolved in water. So that is not a solid. G is a gas. L is a liquid. And S is a solid. So we know based on the question we're looking for definite shape, definite volume. That is the definition of a solid. So that means choice D is the answer. Number 3. Given the particle diagram representing 4 molecules of a substance, what particle diagram best represents after a physical change? Again, physical change, no new substance is formed. So we're looking at this, and we have a white circle and a black circle connected. So if we look at choice A, so basically here we have a white and a black circle connected. So we still need a white and a black circle connected in our answer choice. So choice A, we have a black and white circle, a black and white molecule, black and white, black and white. That looks just like this one. They look exactly the same. But let's just keep looking. With B, now the things have completely come apart. So a black and white compound connected is different from when they are disconnected. So this is a chemical change. With C, we still have 4, molecules, but we have all white ones and we have all black ones. That's different from what we started with, so that is a chemical change. And for D, now we only have 2 molecules, and this whole thing is different from what we started with, so that is also a chemical change, leaving choice A to be the only physical change. Now, in this box, this original box, we have the elements, or the compounds rather, in the gas form, but in choice A, they are now in their solid form. So this was a phase change. And remember, all phase changes are physical changes. Because you have P for physical, P for phase. Okay, moving on. Number 4, when a mixture of water, sand, and salt is filtered, what passes through the filter paper? So it might help if you draw yourself a little picture. Here is, a beaker of stuff. Sand collects at the bottom. So there is your sand. And then the salt dissolves in the water. So that is salt. Now, when you pour it through a filter into another beaker, and this goes through, what happens is that all the water passes through and all the salt, because remember, the salt is dissolved in the water. You can't really see it. So the salt water passes through, but the sand is too big to fit through the filter paper. So the sand gets stuck right there. So sand gets stuck, and in here, now we have salt water. If we wanted to get the salt and the water separated, then you would have to let the water evaporate. But in terms of this question, it says what passes through the filter. So everything except for sand, and that is answer choice C. Number 5 says the arrangement of particles is most ordered in a sample of. So most ordered, if we think about, most ordered and least ordered, we're thinking about phases of matter. So a gas, remember, is the least ordered thing. So if we draw a particle diagram of a gas, they're just randomly spread out. The most ordered is a solid. Because if we have a particle diagram, they're very, very organized like that. And then liquid is somewhere in the middle. So again, most ordered, we want a solid. And so just to recap this again, AQ is aqueous, which means that compound dissolved in water. So if something dissolves in water, it's technically a liquid. L is liquid, G is gas, S is solid, so our answer choice has to be D. Number 6. Number 6 says distillation is a process used to separate a mixture of liquids based on different. So the answer here, if we're talking about distillation, there are 2 things you need to know about distillation. You separate liquids, and you separate them based on boiling point. So choice A. So basically what happens with distillation, you have a liquid. So let's say you have, alcohol and water. Both of those are clear liquids, so they look exactly the same. But you want to get them separated, and you can't exactly pick apart molecules because that doesn't, first of all, make any sense, and second of all, it's not really that possible. So you stick it, and this is a very bad drawing, but you stick it into a distillation setup, and so this is your condenser tube, and it's connected to, here's a little opening, and there's a little beaker underneath it. Now, under the flask, there is a Bunsen burner or some kind of heat source. So what happens? This liquid gets heated up, but there are 2 liquids in there. Both liquids have different boiling points. So the boiling point of the alcohol is about 74 degrees Celsius, and the boiling point of water is about 100 degrees Celsius. So when this gets heated up, and when this liquid reaches a temperature of 74 degrees, the alcohol boils up and turns into a gas, has nowhere to go, so it follows this tube down. Now, in this condenser tube, you have cold water passing through, and the condenser literally condenses the gas. So it turns it from a gas into a liquid. So now, the gas is turning into a liquid, and the liquid of the ethyl alcohol gets deposited in that second beaker. Now, only the water is left behind here, and the alcohol is there. So again, that goes by different boiling points. Number 7. This one looks like a lot of words. It's okay, we'll unpack this together. 7 says, which statement describes the type of change and the chemical properties of the products and the reactants? So we're starting off with this, and we're ending up with 2 of those. So we're talking about, if we look at the answers, we're looking at physical change, chemical change, chemical change. So first, let's ask ourselves, what kind of change do we see? And our question should be, did we make something new? And the answer is yes. We started with this, we're ending with that. It is different. So that means we have to have a chemical change. So that means we can get rid of choice A and B. So now that we've narrowed down our answer choices, let's take a deeper look into C and D. So choice C says the product and the reactants having different chemical properties, and D says products and reactants have identical chemical properties. So think back to the example when we had mentioned sodium metal and chlorine gas. Together, sodium metal is an explosive metal when you put it in water, and chlorine gas is toxic. But when you put them together to make NaCl, you have table salt, which you put on your food. So that means the different chemicals have different chemical properties, and that is answer choice C. Number 8, it says an aqueous solution of sodium chloride is best classified as. So again, aqueous solution means dissolved in water, and you'll see it written as AQ. And so whenever you see this, you should always think homogeneous, because if you think about salt water, you can't see the salt in the water if it's dissolved completely. So this is a homogeneous mixture, which is answer choice B. Now I want to point out that a homogeneous compound does not exist. It's there to confuse you, and that's it. A heterogeneous compound, again, does not exist. The Regents question writing people are like, well, how can we confuse students with this question? Let's just make stuff up. So they do that. Do not fall for that. So that would just leave you with choice B and D. And again, whenever you have AQ, you should always think homogeneous mixture, because it's that compound dissolved in water, and generally if it's dissolved completely, you do not see those pieces. Everything is evenly spread throughout, so that is a homogeneous mixture. Almost done. Number 9. Number 9 says, which particle diagram represents a mixture of an element and a compound? So one of the first things you need to do when you have a particle diagram, or something I highly suggest, is label all the different pieces in your box. So if you look here, we have a black circle and a white circle connected together. And that, if you have 2 or more different colors connected, that is a compound. And all the other things are the same. So they're all compounds. Now, in box B, any singular element any singular circle all by itself is an element. And we can even say it is monoatomic, because it's one atom of one element by itself. So this black circle is that as well. But these two, if you have two or more of, not two or more, just two of the same color connected, that is a diatomic element. Again, if you have two of the same color, that's an element. If you have two or more different colors, that is a compound. But if we're just going to look at this, in total, we just have elements here. If we look at choice C, here is a diatomic element because you have two of the same colors connected, and the black one is also a diatomic element. So all of these are diatomic elements. So again, it's just elements. There's no compounds in there because the question says element and compound. A just had compounds, B just has elements, C just has elements. So if we look at D, again, if you have two of the same color connected, you have a diatomic element. And if you have two or more different compounds, or two or more different colors together, that is a compound. And this compound is not connected to this element. So they're an element and a compound in the same place at the same time. That is the definition of a mixture. So, answer choice D. Last question. Question 10. Question 10 says 2 grams of potassium chloride are completely dissolved in a sample of water in a beaker. This solution is classified as. So whenever you see completely dissolved, you should think aqueous solution. Aqueous solution, you should think, okay, well that's symbolized AQ, and it is always a homogeneous mixture. If it says completely dissolved, that means there's nothing chilling at the bottom. It's all evenly spread throughout. The composition is uniform. That is a homogeneous mixture. So that is our answer, choice C. So that's it. Hope this review video helped. Do the practice questions again if you want. Have fun. Bye.